Hey everyone, unprecedented images of 3I Atlas have just arrived, and they completely change our understanding of this mysterious object. These last-minute observations were captured on the 11th of November 2025 and show something absolutely surprising, something that astronomers were not expecting even in their most optimistic scenarios. 3I Atlas remains as a single body with no evidence of fragmentation after its perihelion passage 2 weeks earlier. This is significant because most researchers anticipated that if 3I Atlas were a typical comet-like body, the intense heating near the Sun would have caused at least partial breakup or disintegration. Yet here it is, stubbornly intact, defying assumptions. The images you're seeing now were obtained by David Jewett and Jane Liu using the Nordic Optical Telescope, which is equipped with a primary mirror measuring 2.56 meters in diameter. This instrument sits atop the rugged volcanic terrain of La Palma in the Canary Islands, a place known for excellent atmospheric conditions and some of the darkest skies in the Northern Hemisphere. These observations aren't just routine snapshots. They are crystal-clear visual data coming from some of the best observational equipment available to ground-based astronomers. And this changes everything in ways that are only starting to become apparent. But what do these new images really mean? To help make sense of them, Avi Loeb just published a devastating and highly detailed article on his blog analyzing these observations, and the results are simply explosive. Loeb not only confirmed that the object remained intact, but he made calculations that challenge and, in some cases, directly contradict the conventional explanations about the nature of this interstellar visitor. His analysis raises deeper questions about whether our traditional models of cometary behavior can be applied to something coming from outside our solar system. Let's take a deeper look at the analysis that could reshape our understanding of what is actually passing through our cosmic neighborhood. According to Loeb, the glow surrounding 3I Atlas shows a prominent elongation that projects to a position angle of 106 degrees, very close to the projected sunward direction of 115 degrees. This is not a trivial detail. Such alignment suggests that whatever is causing the elongated glow is responding in a highly organized way relative to the direction of the Sun. This closely resembles the image obtained by the Hubble Space Telescope on July 21, 2025, which had already shown an anti-tail pointing toward the Sun, something counterintuitive and rarely seen in natural comets, where tails almost always point away from the Sun due to radiation pressure. The new image also reveals a much weaker asymmetry at an angle of 301 degrees, close to the projected anti-solar direction of 295 degrees. Even small discrepancies like this can reveal details about the distribution of particles around the object and the forces acting on them. At the moment of observation, 3I Atlas was 1.43 astronomical units from the Sun and 2.16 astronomical units from Earth. For scale, the entire image region spans roughly 500,000 kilometers, large enough to encompass the Earth and its moon with room to spare. Loeb explains that the long-range jet structures evident in recent wide-field images are not visible in this data, likely because the observations were made through an RBN filter. This filter effectively blocks most gaseous emission lines, meaning that if the jets were composed largely of specific gas species, they would be heavily muted or invisible. This is an important technical note, because it shows that the absence of jets in these particular images does not necessarily contradict earlier detections. It simply reflects the limitations and specific behaviors of the observing equipment. And now comes the turning point in Loeb's argument. He writes that given the large-scale jets observed previously, the fact that 3I Atlas remains a single body is profoundly surprising for a natural comet. If a comet were emitting jets of such magnitude, the forces involved would normally exert substantial mechanical stress on the nucleus, increasing the likelihood of cracking, splitting, or complete fragmentation. Pay close attention to the numbers Loeb cites. Large-scale images of 3I Atlas show jets extending roughly 1 million kilometers toward the Sun and an astonishing 3 million kilometers in the opposite direction. These aren't small puffs of material, they are monumental outflows on a planetary scale. According to Loeb, the outflow velocity for natural comet jets at 3I Atlas's distance from the Sun would be around 0.4 km/s, roughly the speed of sound in gas under those conditions. For any material to reach those distances at that speed, the jets would need to remain active over 1 to 3 months. This sustained outflow implies a level of mechanical and energetic stress that few natural comet nuclei could withstand. But this is where Loeb's calculations become dramatically more troubling. Given that the jets pointing toward the sun were halted by solar wind at around 1 million kilometers away, Loeb determined that their mass density must be on the order of a few million proton masses per cubic centimeter at that distance from 3I Atlas. Combining this mass density with the outflow speed indicates a colossal mass flux, around 5 billion tons per month, over an area 1 million kilometers wide. These numbers, while extraordinary, are derived using standard physics and conservative assumptions, which is why they pose such a severe challenge to natural explanations. Next comes a devastating critique of the energy budget required to sustain such activity. Sublimating carbon dioxide ice requires 600 joules per gram. To eject around 5 billion tons of CO2 over a single month, 3I Atlas would need to absorb at least 3 times 1018 joules of energy. At its perihelion distance, the Sun delivers energy at a rate of about 700 joules per square meter per second. For 3I Atlas to absorb enough energy to drive this outgassing, it would need an absorbing area over 1,600 kilometers across. This corresponds to a sphere with a diameter of 23 kilometers, 4 times larger than the maximum diameter of 5.6 kilometers estimated from Hubble observations. And if the outgassing were water ice instead of CO2, the required diameter would balloon to 51 kilometers. Loeb then highlights one more critical point. On natural comets, volatile pockets typically occupy only a small percentage of the total surface. This means the effective area capable of sublimation is significantly smaller than the object's geometric area. When this is taken into account, the numbers he calculates become not merely unlikely, but physically untenable for a body the size of 3I Atlas. In other words, a natural comet simply cannot expel such vast quantities of material while retaining its structural integrity at the observed size and without fragmenting. And then Loeb delivers the most direct critique yet. He argues that this creates a new, unexplained anomaly, one that anyone attempting to defend the natural comet interpretation must address. Ignoring these anomalies, he suggests, is akin to sweeping inconvenient evidence under the rug of traditional comet theory. To underscore the point, he quotes Albert Einstein, "Knowledge is realizing that the street is one way, wisdom is looking in both directions." The message is clear: sometimes progress requires acknowledging when familiar frameworks no longer fit the data. As Loeb emphasizes, there is a fundamental new anomaly here that demands explanation. And maybe it really is time to look both ways down the street, just as Einstein suggested. What do you think about Loeb's expanded analysis? Do these numbers and observations convince you that something is fundamentally off in our current understanding of 3I Atlas? Share your thoughts, your theories, and your interpretations, because this story is clearly far from over, and the debate it's creating may reshape how we look at interstellar visitors for years to come.